Good morning, sir. Myself V. Purnachandra. I am pursuing BTech in the Department of EC, bearing roll number 24BQ1804I1. Today, I want to tell a seminar on the topic about binary codes. In binary code, I would tell about the introduction of the binary codes, types of the binary codes, and the needs of the binary codes. And later, I would tell about the applications of the binary code. Binary code are a system of representing information using only two digits. It is 0 and 1, which are called binary digits or bits. This form of coding is the fundamental languages of digital computers and electronic systems. The fundamental language of digital computers and electronic systems computes only uses binary codes because their hardware are easy and easily represent two states, typically 1 and 0. Binary codes can represent numbers, letters, symbols, and instructions for processing data or controlling operations with digital electronic devices. The binary code is a system of representing information such as numbers, letters, or symbols. It is using only two digits, 0 and 1. The digital computers also work with the binary codes. Now I will tell about the introduction to the binary codes. It is essential for communication between the humans and machines. It can represent numbers, letters, or symbols and instructions for processing data or controlling operations with digital devices. Binary code it is essential for group of bits representing information. It is a base 2 system. It is 0 and 1. Now I would tell about the types of the binary codes. In binary codes, there are four types: weighted codes, non-weighted codes, alphanumeric codes, error detecting and error correcting codes. Now I would tell about the types of binary codes. In binary codes, there are four types: weighted codes, non-weighted codes, alphanumeric codes, and error detecting and error correcting codes. Now I would tell about the weighted codes. In weighted code, each bit has a positional weight. In weighted codes, each bit in a binary number has a specific weight based on its position. The weight is generally a power of 2, starting from 2 power n equal to 1 at the rightmost to 2 power n at the leftmost. The examples of the weighted codes is 8421 binary coded decimal, 2421 code, 5211 code. Now I tell about the 8421 binary decimal code. It represents digits from 0 to 9 with a 4-bit binary code. For example, decimal 11 is 1011 in binary, where weights are 8421. Other weighted codes, which include 5211, 82421, 6311, and 21 codes. Weighted codes are used in arithmetic operations and digital circuits, but sometimes require special handling for weighted and subtraction. In binary coded decimal, each decimal digit has 4-bit binary codes. Now I would consider 0. For 0 in binary coded decimal, it is represented as 0001. For 1, it is represented as 0001. For 2, it is represented as 0010. For 3, it is represented as 0011. For 4, it is represented as 01000. For 5, it is represented as 1001. For 6, it is represented as 1010. For 7, it is represented as 1011. For 8, it is represented as 1000. For 9, it is represented as 1001. For 10, it is represented as 1010. For 11, it is represented as 1011. For 12, it is represented as 1100. For 13, it is represented as 1101. For 14, it is represented as 1110. For 15, it is represented as 1111. It is easily conversion between decimal and the binary. For example, I would consider as 59. In binary coded decimal, the 5 is represented as 0101, and the 9 is represented as 1001. For 59, it is 0101 1001. Weighted codes are used in arithmetic operations and digital circuits, but sometimes it requires special handling for addition and subtraction. The binary coded decimal is a type of weighted code. For each decimal digit represented by 4 binary codes. Through 4 bits can represent 16 values. Only the first 10 are valid for BCD, then rest for valid. It is mainly used in calculators, digital electrodes, and devices performing decimal arithmetic. It simplifies the conversion between the binary and decimal, but is less efficient than pure binary. Now I would tell about the non-weighted codes. It has non-positional weight. These codes do not assign potential significance for bits. The values are defined definitely. The examples for the non-weighted codes is XS3 code and the gray code. XS3 code means encodes decimal digits by adding 3 and then converting it to binary. Gray code, a cyclic code where due to numbers differ by only 1 bit to minimize errors in digital communications. The non-weighted codes are used to reduce error propagation and simplify specific types of computers and error detection. Now I would tell about the XS3 code. That XS3 code is known as decimal digit plus 3 in binary form. For example, we consider as 5. The XS3 code is 1000 plus 3 1010. It is the XS3 code. It is used in digital arithmetic and the error detection. Now I would tell about the gray code. The gray code means only 1 bit changes between two successive numbers. It reduces errors in the transmission. For example, decimal 0 to 7, the gray code is 00 for 0000, for 1001, for 2011, for 3010, for 4 1100, for 5 1111, for 6 101, for 7 100. Now I would tell about the alphanumeric codes. It is a third type of the binary codes. It represents only letters and symbols. Now I would tell about the alphanumeric codes. The alphanumeric code represents letters and symbols. The examples for alphanumeric codes is ASCII and EBCDIC. The ASCII stands for American Standard Code for Information Interchange. The EBCD stands for Extended Binary Coded Decimal Interchange Code. And then another example for alphanumeric code is Unicode. Now I would tell about the ASCII code. ASCII code means American Standard for Code Information Interchanges. It uses 7 or 8 bits represent characters. It represents characters. For example, capital A equals 65 and small a equal to 97. It is widely used in the computers. Now I would tell about the EBCD, so Extended Binary Code Decimal Interchange Code. It is another character encoding. Mainly it is used in IBM systems. These codes are essential for text processing and the communication. Now I would tell about the fourth type of the binary codes, error detecting and the error correcting codes. Now I would tell about the error detecting codes. It ensures accuracy in the data transmission. The examples of the error detecting codes are parity bits. The parity bits means simple error detection by making the number of ones even or odd. Hamming code. It is used for both error detection and correction by adding redundant bits. These codes are enhanced by data reliability during transmission storage. The examples of the error detection codes is parity bits, checksum, cyclic redundancy check. Now I would tell about the error correcting codes. It detects and correct the errors. The examples for error correcting codes is Hamming code. It is used for both error detection and error correction by adding redundant bits. Reed-Solomon code. It is used in memory and communication codes. In binary codes, the additional classification also, it is known as sequential codes. The sequential codes means where each successive code differs from the previous by a defined pattern. It often by adding one. The examples are BCD 8421 XS3 and cyclic codes. The cyclic codes are successive codes differ by 1 bit. Self-complementing codes in which of the complement of a number represents the 9th complement in decimal. XS3. The binary codes are diverse and tailored to different needs such as numeric representation, text encoding, error control, and minimizing errors or complementing in digital systems. Each type has specific advantages and resilience. Now I would tell about the applications of the binary codes. The binary codes have a wide range of applications across various digital systems and technologies due to their simplicity, efficiency, and compatibility with electronic devices. Here are the key applications of the binary codes. Computing and digital First I would tell about computing and digital devices. Binary code is the foundation of all modern computing systems. Data, instructions, and operations in computers are represented and processed in a binary form. Central processing units (CPUs) uses binary codes to execute logical and arithmetic operations efficiently. Binary codes represent everything from numbers and text to orders and instructions used in digital devices. Now I would tell about the application communication system. Binary codes enables data transmission over networks including wires, cables, fiber optics, and wireless communications. It is used in data storage in computers and storage devices and are stored in binary format or compact and reliable storage. It is used in digital storage processing Digital images are represented and as pictures in binary form, allowing operations such as image enhancement and compressions. Audio and it is used in audio and video signals are converted from analog to binary digital signals for processing, storage, and playback. It is embedded systems and microcontrollers. Embedded system uses binary codes to control devices automatically based on instructions in binary. Microcontrollers in devices like microwave ovens, remote controls, and sensors operate with binary coded instructions. It is error detection and correction. Binary codes incorporate techniques such as parity bits and Hamming codes to detect and correct errors using data transmission and the storage. Binary codes are the foundation of digital systems used for numbers, text, error detection, and the correction. It is widely used in computers, communication, and the storage. These are the widely applications of the binary codes we used in daily life situations. Now, these are the topic about the binary codes. Thank you for giving me this opportunity.